Hi, here's our second lesson on zero and negative exponents. When we see exponents written as fractions in this case, what this means is really 3 times 3 times 3 divided by 3 times 3 times 3 times 3, oh my gosh, times 3, like that. But I'm not going to expect you to write that out every time. You notice that these 3's would cancel with what is in the denominator. So we really end up having 1 over 3 times 3, or just 1 over 9. But there has to be an easier way to think about that. So one of our exponent rules is that when you're dividing powers that have the same base, so they both have a 3 as the base, you can subtract the exponents. So another way we might have written that instead, I'll do it up here, we might have written that as 3, and then 3 minus 5 is negative 2. So we could have said, oh, that equals 3 to the exponent negative 2. But what we'll talk about today is that I don't want you, it's not really proper to leave your answer with a negative exponent. So let's look at this one. If this was your question and we don't want to write that out every time, we have the same base, and so we can subtract our exponents. So that would be the same thing as 2 to the negative 4, because 2 minus 6 is negative 4. So having a negative exponent, what that means is we're going to imagine that this 2 is really a fraction, like 2 over 1, and we kind of imagine that fraction. We need to write down the reciprocal of that fraction. So we write that fraction upside down, we flip it, and then what that means is that fraction now has the exponent positive 4. So negative exponents, you would use the reciprocal of the fraction, and if it's just a 2, you want to make it a fraction, 2 over 1. And when I flip that upside down, I have 1 over 2, and now it's just to the exponent 4. Another way you'll see it written here and there, or a lot of teachers will write that as 1 over 2 to the 4th. So I guess because we end up with a 1 in our numerator, they kind of know that 1 times 1 times 1 times 1 is just going to be 1. No matter what the exponent is, it's just going to be 1. So they're just worried about the denominator being 2 to the 4th. I kind of like writing it as an entire fraction to the 4th, and we'd get 1 over 16. And that would be our answer. So we wouldn't leave our answer with a negative exponent. This is a much preferable way to write your final answer. This one, imagine here there's this exponent of 1. So we have the same base. 1 minus 3 is negative 2. So this is 4 to the exponent negative 2. But that should remind you that, oh wait, I can't leave my answer like that. 4 is really 4 over 1. So if I use the reciprocal, 1 over 4, that now is to the exponent 2. So the negative exponent turns into just a positive exponent as long as you use the reciprocal, and that's 1 over 16. Okay. This one over here, this is just more of the same practice. If you have a variable, 3 minus 7 is negative 4, so we still have the same base here. It works with a variable as well. I wouldn't leave my answer still, even though it's a variable with a negative exponent. That's x over 1. So 1 over x to the 4th. And I think a simpler way to write that would just be 1, because 1 times 1 times 1 times 1 is 1. And then the x would have the exponent of 4 if it was simplified. Another one with variables over here. So that is 1 minus 3 is negative 2. So z to the negative exponent negative 2, that would be 1 over z squared. And then 1 times 1 is 1, and z squared is just z squared. So here's a little rule on the side. They are just showing that the denominator is the one that ends up with that exponent, just because 1, this could also be written as 1 to that exponent, or also with all of that as a fraction to the exponent n. So more of the same. This is a little different though. When I subtract these exponents, 3 minus 3 is 0, so that's 5 to the exponent 0. Well, if I had numbers that were exactly the same top and bottom, like 10 over 10 or 1,000 over 1,000, that is actually equal to 1. So if you imagine these canceling out, that is the same thing as 1. So any exponent that is 0 gives you an answer of 1. So 5 minus 5 is 0, but anything to the exponent 0 is 1. On the next page, we see variables. Same thing works with variables. So if I subtract my 2's, that's just 1. If I subtract the y's, y minus y is 0, so that's just 1. And if you see a question that just says, oh, what's 8 to the exponent 0? If you don't believe me, you can type it into a calculator. 8 to the exponent 0 is 1. R to the exponent 0 is 1. You could have some really big these could all have exponents. It doesn't matter. If it's to the 0, anything to the 0 is 1. So that's something you'll have to remember as well. And then a few more questions here. Evaluate each of the following. So if you see the word evaluate, that means we do want the final answer. So one step of this, if I see 5, negative 5, that's negative 5 over 1. If I flip that upside down, I get 1 over negative 5. And this exponent becomes a 3. So my answer for that one would just be 1 over 125, but negative 5 times negative 5 times negative 5, there's 3 negatives, so that's an odd number of negatives, so I would have 1 over negative 125. This one over here, and the negative can go anywhere. You could write it in the numerator, you could write it out here, right on the side. This fraction is negative because you see 1 negative there. When you actually have a fraction and I want to use the reciprocal, I don't imagine there's a 1 down here. It's 3 over 4, so the reciprocal of that is 4 over 3. And the exponent, once I've done that, becomes positive 3. So I'd need to find out what 4 to the third is and 3 to the third. So fractions, you do each one separately. If you don't have a calculator at home, just know that you can go just Google scientific calculator, and I can type in 4 to the exponent 3, 4 to, there's your exponent button, to the exponent 3. So if you don't have a scientific calculator at home, you can do it online as well, and it gives you 64. So just to point that out. So here our answer 64, which is 4 times 4 times 4, and then 3 times 3 times 3 is 27. And I'm pretty happy if you just leave your answer like that. So we're getting into a little bit more here. 7 to the 0, that's 1. Minus, now this 2 to the negative 2, that is over 1. So we would write that as 1 over 2, but that would become just squared. So 1 minus, 1 times 1 is 1, 2 times 2 is 4. 1 minus a quarter, we could get common denominators and do all of that as well. This would be 4 over 4, but I think you know that 1 minus a quarter is 3 over 4. Okay, this one over here is a little bit, there's a little more to this one. You see a lot of negative exponents here. So each one, imagine that's 2 over 1. So that would become 1 over 2 to the exponent 1, which is just 1 over 2, plus 2 is 2 over 1, so 1 over 2. 1 over 2 to the exponent 2. Divided by 3 is 3 over 1, so that becomes 1 over 3 if I use the reciprocal, and that's to the exponent positive 1 now. Okay, so what are we going to do with that? 1/2 is, to the exponent 1 is just 1/2, plus 1 over 2 squared is 1 over 4, because 1 times 1 is 1, 2 times 2 is 4. And this is just divided by 1 over 3. Okay, so maybe in the numerator we'd like a common denominator so that we could add them together. So this is bringing back all the rules of fractions that you've known for a long time but probably are a little rusty on. If I want a common denominator, I would have to multiply the top and the bottom, the numerator and the denominator, both by 2. So I would get 2 over 4 plus 1 over 4 divided by 1 over 3. So this just keeps going here. We have 2 quarters plus 1 quarter, that's 3 quarters, divided by 1/3. Now that looks pretty weird, and my 3 looks a little weird. I call this like a double-decker fraction. You have 2 fractions and this dividing line in the middle. I like this much better when it's written like this. What if it was 3 quarters divided by? So instead of using this divided by line, what if I wrote 3 quarters divided by 1/3? To me, that makes much more sense because I remember a rule. When I'm dividing fractions, I invert, so I flip this one upside down. Do you remember? Invert and then multiply. So what that would equal would be 3 over 4 times 3 over 1. So you flip the second fraction upside down and change the division to multiplication. So that's the rule for multiplying fractions, or sorry, dividing fractions. When you multiply, you just go straight across and get 9 over 4. So that would be a fine answer. I don't need a mixed number. We could just leave it as an improper fraction, and that one's done. So this is a really important trick here. I really think this helps me so much. If I ever see fractions in the numerator and fractions in the denominator, I like it written like this so that I know that I invert and multiply. And you're going to have to remember that. So x to the 0, this is just a summary of what we've learned. Anything to the 0 is 1. This one, if it's to the negative exponent, I also like that written as 1 over x to the n, the entire fraction to the n. But really, the 1 times 1 is just going to become 1, so they're just showing the x to the n in the denominator. If you do have a negative exponent in the denominator, what you can do is write that term in the numerator, and then the exponent becomes positive. And this is just a rule of using the reciprocal, flipping a fraction upside down, and then the exponent would become positive. Here is the homework that's also posted in the news item on the LMS, and I hope that it goes well.